Now, functions can be really tricky, and that's what we're learning about now. Section 2.4, we're learning about functions. I did present the definition last time. I want to start with it again, though. Remember, a function from set X to set Y, set X, remember, a set is just a collection of something. For us, it's mostly going to be numbers, but you can really have a collection of anything. A function from a set X to a set Y, okay, by definition is a rule or an assignment that assigns to each element from the first set, each little x from the first set. So little x represents an arbitrary element from the first set, exactly one element from the second set. Exactly one element from the second set. So to each element in the first set, it assigns to it, the function assigns to it one element from the second set. I know I'm repeating this definition a lot. It is important. I mean, if you go on to other math classes, like pre-calc and higher, especially if you're a science major if you're any kind of science major and you have to take calculus, you will study functions. You have to know them, okay? You have to know what they are. And they do come up in other areas as well. So that's what a function is by definition. Little f here denotes the function. Now, really remember, to have a function, what has to happen is you have to somehow specify what this rule is. And whatever you're claiming to be a function has to satisfy this definition. And we will see three ways. We'll see how to specify a function. There's different ways we can do that. One way is through what's called the relation. We'll see that today. You can use equation in x and y to define a function. And you can also use a graph. We'll get to that though. Remember also, everything in the first set is called the domain of the function. The domain of the function, is the first set. Everything that comes out of the function, right, is the range. Let me explain it this way. I'm not sure if you guys have watched like old cartoons, like when you were younger or not. But in some cartoons, there's like an assembly line, okay? Something goes in on the assembly line into this function, this big machine. You don't know what the machine is doing, right? It's doing some crazy stuff. And then after, some sounds and stuff are played, something comes out. You can think of that as like a function. What goes into the function is doing crazy stuff in the background. It might be, I don't know what it's doing, but it's doing something. And for each thing that goes in, something comes out. Only one thing comes out. Or you can think of it this way. Input, this is how I like to think of it. Input goes into the function, and for each input into the function, you get only one output. You get only one output. So for each input that goes into the function, that's your x, that goes in, that's what the arrow's telling us, you get only one output. The set of all your inputs is the domain of the function. The set of all your outputs is the range of the function. The set y doesn't have to be, the entire set y doesn't have to be. It can be, but it doesn't have to be. The range is going to live in set y. And for us, again, sets x and y, they are going to be collections excuse me, sets of numbers. And what we have here is a correspondence diagram. Again, you have these two circles with the correspondence diagram. You list elements in the first set, and you list the elements in the second set, and you can draw an arrow from each element in the first set to an element in the second set. So that's what you can do. So that's what a correspondence diagram is. And we can use that to define a function. For instance, let's suppose x here was this set. I did email the notes also, so you should have them in your inbox. You have the set x, which is 1, 2, 3, 4. We have y, which is 2, 4, 6, 8. We have this correspondence diagram. We have the elements in x listed. We have the elements in y listed. For each element in x, right, we have an arrow drawing it to its output. So the function would be all the arrows together. The function is taking this element 1 as input, and it gives you back 2 as output. 1 is our input, that goes in. 2 is our output. 2 is our input, that goes in. 4 is our output. 3 is input into the function. It goes in, like that assembly line, what do you call it, image I gave. 3 goes in. 6 comes out. Right? 3 goes into that assembly line. The function is doing all this crazy stuff in the background, and it's giving you back 6. That's our output. 4 is the input. That goes in. 8 is the output. And we have a function here. Notice, and we actually do have a function mainly because you have only one arrow coming out of each element in the first set. You only have one arrow leaving 1, one arrow leaving 2, and same with 3 and 4. Here's another example. Actually, hope everyone saw. I didn't mean to leave the slide too quickly. We have another example here. This is also a function. Notice that x and y are the same, sets as in the previous example. The arrows are drawn differently though. So we have a different function, but we still have a function now. In this case, 1 is assigned as input and gives you back the output 8. Before it was 2, now it's 8. 2 into the function, we get back 2 as well. And 2 in this set. 3 is our input. 3 goes into the function, and we get 4. 3 is our input. 4 is our output. 4. Wonderful 4. Our input. 6 is our output. So that's what our function is doing. Again, we have a function here because from each element in the first set, there's only one arrow coming out of each element. This is our domain. These are all the inputs. This is our range. In this case, y, all of set y is the range. Again, that doesn't have to be. Y could be all real numbers, and then just this set would be the range. Here, however, we have something different, don't we? As you can see, this is different because, as you can see, you have two different arrows coming out of 1. I mean, right away we know this is not a function. I know I didn't finish the diagram, but right away we know it's not a function. Because the first arrow is assigning 1 to 2. The second arrow is assigning 1 to 8. You have 1 as input, but 1 has 2 different outputs. Though this is assigning to 1 2 different elements from y. I mean, if you went back to the definition, let me get back there. Here we go. What the function has to do is to each x in the first set, it has to assign to it exactly one element from y. So here in this picture, the function is assigning to x 1 y. Whereas, let me get back to that picture here. This here is assigning to 1 2 elements in y. So it's not a function. I mean, that whole exactly one element thing is very important. You can think of it this way also. You know, if you have your calculator and you want to take the square root of something, say the square root of, I don't know, 9, right? Well, if you press 9, then press the square root button, what if the calculator gave you 2 different answers? I mean, well, which one would you use on a test? Which one would you tell me if I ask you what's the square root of 9, right? You don't know which one to use, which one to say. That whole exactly one element business is very important. Okay. Let me pause the recording.